Ladies, gentlemen, good morning. This is Germinal Van, and today is a very special video. In fact, it is a request from some of my followers on Instagram who asked me to make a video about how to create a mathematical model. So this is what we're going to talk about today. I will try to be brief as much as possible, but I also want you to give the most crucial information you need in order for you to get started. So first and foremost, the notion and concept of mathematical model has scared people, including myself. And I know a lot of people want to start using mathematics in their work, but they don't know how and where to start. So this is what I'm going to guide you through. So first and foremost, what is a mathematical model? So a mathematical model is simply a theoretical framework to model a real world scenario. Okay, so a mathematical model is in fact a simplification, all right, of a real world scenario. So you are basically trying to explain a real world phenomenon. That's why we start developing mathematical model. It's for us to have an understanding of what's going on. Of course, a mathematical model cannot take everything into account. It is impossible. That's why the skeleton of the model is a simplification of it. All right, and then why do we create this? Why do we create a mathematical model? So the purpose is that it creates a path that leads us to the testability. I don't know if testability is necessarily the right word, but I use the word testability anyway. So it leads us to the testability of the model. So we don't create the model for fun. We create it so that we can find a way to test it, right? And why do we try to test it? We test the model to find practical solutions. Okay, so we test the model to find practical solutions. And what are the other benefits of a mathematical model? So it helps us clarify our assumptions and statements. So when you create a mathematical model, right, the purpose also is that you first develop your set of information using a priori, the a priori method. Let me put it here. A priori method. So all your assumptions are a priori. So you're describing a scenario. So it has to be a priori, and then you now develop the mathematical model in order to clarify if what you've developed verbally holds. Because when you develop a theory verbally, you can get lost in the process. It doesn't mean that you will necessarily get lost, of course not, but you could. So you use mathematics as a rhetorical device to see if everything you said in the a priori information holds in the mathematics. So all the big variables, so everything you stated that are part of what you're going to be tested are the variables. So you want to make sure that all the variables you mentioned in the a priori part are also represented in the mathematical model. So these are some of the principles of, or should I say, the basic principles of mathematical modeling. And now the next is the types of models. So what are the types? In fact, the four types. You first have dynamic systems. Dynamic system is one kind of mathematical model. I personally don't know how to use them. It's something I have to work on. You have statistical model. This is what I do for a living, so that I know pretty much. I use that for econometrics all the time. Then you have differential equations. Okay, and then you have game theoretic models. All right, so you have dynamic systems, statistical models, differential equations, and game theoretic models. So what I know for sure are these two: statistical models and differential equations. Game theoretic, I'm not too keen on that yet, but it is used extensively in public choice theory, which is the school of thought that I'm in economics. So now the question is, where are mathematical models used? In fact, they're used everywhere. Even in the water that you drink, it's based on the mathematical model, because the process of cleaning water is based on any of these models used. They can use, so like, let's say the pipeline company can use dynamic systems to develop the process, or they can even use statistical models if there is a data, right? If there is a data, they can use that data to see the historical trend and then predict or explain. Or they can use differential equations to also develop the process of cleaning water. So this is how far it goes. Like, it is used pretty much everywhere. So here, what I'm going to show you are basically the field of study. So of course it is used in economics. I start with econ because that's what I'm in. It is used in political science. Okay. It is used in history through plyometrics. It is used in physics, of course. It is used in biology. It is used in chemistry. It is used in computer science, specifically through discrete mathematics. It is used in computer science. It is used in engineering. Okay, whether it's mechanical engineering, civil engineering, biomedical engineering, electrical engineering, all kind of engineering you want. It is used in finance. A lot of people use mathematical models all the time to make billions in finance. It is used in accounting. That's what they use to develop new tax code. It is used in law. Yep, in law. In law, you may say, how you use mathematical models in law? Well, you use mathematical models in law to determine jury behavior. All right. So you use that. It is used in music. Yep, even in music, specifically in music theory, you use mathematical models to determine the pattern of musical notes or even like sounds. So you basically, people will use differential equations for that. It is also used in philosophy. It is used in philosophy. So there is a branch of philosophy called analytical philosophy. So for people who read a lot of philosophy, Robert Nozick and Bertrand Russell were two analytical philosophers. So they used math to, in fact, develop their philosophical doctrines. So you have, so let me put it here, analytical philosophy, right? So it is used in analytical philosophy. It is used in sociology a lot. There's a branch called mathematical sociology, and it is used in psychology. And there's also a branch called mathematical psychology. It is used in anthropology. I don't know if I'm missing any other field of study, but these are the field of study that comes to mind. And mathematical models are used in any of these fields of study. So it is amazing. It is amazing what you can do with math. Yeah, it's everything we do, everything we use are based on mathematical models. That's why I've been insisting on people learning how to use mathematical models. It's very important. Now, which math techniques or subjects are used to create models? So you have, of course, so it is important to understand that a mathematical model does not need to be extremely complicated. The level of difficulty of the model is based on the real world scenario you're trying to describe or you're trying to predict. If the scenario that you're analyzing is a very complicated scenario, then your model is going to be complicated. For instance, the Black-Scholes model for option pricing, it's a very complicated model that uses a lot of partial differential equations. But it's because in order to set those option pricing, there is a whole complex mechanism you have to go through. But a mathematical model can simply start with algebra 1, okay, algebra 2. You can also use some notions in pre-calculus such as complex numbers. Differential calculus. So such as derivatives, integral calculus, multivariate calculus, which is normally known as calculus 3, multivariate calculus, linear algebra, okay, this is for matrices. You can use it for you can use real analysis too. Real analysis is something I need to dive into because I have no notion of real analysis yet. You can use topology, okay. You can use topology. You can use what else am I missing? Regression analysis in statistics, okay. Regression analysis. So yeah, these are some of the techniques that you use to develop your mathematical model. But again, it is important to understand that everything is based on the real world scenario you are describing. So let's say, for instance, that you are trying to use a mathematical model based on a differential equation. In order to use differential equations, you have to know differential calculus and integral calculus. Specifically integral calculus. You cannot do differential equations without knowing integral calculus. It is impossible. So you need basically to upgrade your math skills, and then you are pretty much good to go. So where, and let me say, in which industry mathematical models are used? They're used everywhere. In fact, industries use it every day to determine how they're going to allocate their resources. In healthcare, it is used to determine the spread of disease and how to contain that spread. In fact, there is a very famous mathematical model used in biology called the SIR model. Okay, the SIR model stands for people who are susceptible to be infected. That's the S stands for. Okay, the I stands for infected, people who are already infected by the disease. And then you have the R for people who have recovered. So who can no longer be affected by the disease. So the SIR model is used in mathematical biology and even in medicine. Oops, I even forgot. Now that we are coming back to the fields where it is used, you have medicine. Forgot about this. Okay, so you have medicine. So this is used in healthcare to determine how disease are spread and contained. Okay, and that's the model they use, for instance, for COVID, to determine where COVID is going to go, how we can contain it, and the vaccines and they develop a vaccine accordingly to the SIR model. So, and that's even how I learned how to develop mathematical models using differential equations, the SIR model. If you want to know how to use this, there are many videos on YouTube where you simply type mathematical model, and the SIR model is one of the first videos that will appear when you're looking for mathematical model videos. Okay, so now I'm going to show you the process of mathematical modeling, and then I'm going to give you a very simple example, and then that's it. All right. Okay, so here we are going to deal with, I have sweat hands for some reason. We are going to deal with the cycle of mathematical modeling. So the cycle of mathematical modeling is based on 7 steps. So one is basically to specify the problem. You gotta specify the problem. You gotta say, what am I talking about? What is the real world scenario am I describing, right? So specify the problem. That's the real world scenario. Okay. 2, you gotta set up a metaphor. Set up a metaphor. So set up a metaphor is the most crucial part. Your assumptions. Okay? Your assumptions. That's where you actually building the model verbally. That's where you use a priori methods. Okay? That's where you're building your model verbally. You said you're basically saying this occurs because of this, therefore if this happened then this could happen. That's the part where you set up the metaphor. And then here 3, that's when you formulate the mathematical model. That's where you are basically transitioning the verbal reasoning into mathematical reasoning. So you're transitioning from the verbal language to the mathematical language. Everything you say in your assumptions verbally, you write them into mathematical language in a form of equation. Then you are going to solve the equation. You're going to solve the mathematical model. Okay? You're going to solve the mathematical model. 5, you're going to interpret the result. Okay, I'm going to interpret the result or the results, depends, and or solution. And then 6, you're going to compare your results with reality. So let me put it here, confront your solution with reality. So basically the data. And then 7, you have to use it to explain, predict, or decide, pretty much, or even design too. There we go. That's how you develop a mathematical model. Okay, so let me try and put it. So you first start with by specifying a problem. So it goes like this. Okay, 1, 2, 3, 4, 5, 6, and 7. That's your mathematical model. Oops, let me put it so you won't think it's 16. Okay, so this is the cycle of a mathematical model. So you first specify the problem, so you describe the real world scenario that you're trying to understand and solve. You set up a metaphor. The number 2 to me is the most crucial part. So I'm putting this star here. It is crucial. You set up a metaphor. So basically you create an a priori framework. You create a theoretical framework based on the a priori method. And then You move to the third part, which is to formulate whatever you describe here in a mathematical language. Okay, you describe that into a mathematical language, and then you solve the model. That's where you're going to use your differential equation or your statistical model or your theoretic game or your dynamic system. It depends on the scenario you are describing. Then you're going to interpret the solution, the results, and then you're going to confront that with the reality, with the data. You see if whatever model you describe is conform with the data. If it is, your theory holds. If it's not, you got to refine it. There's no shame in developing the wrong mathematical models. Like scientists always develop wrong mathematical models at first. And then you use that model to explain, to predict, to decide, or to design. You need to understand that a mathematical model, so the cycle, in fact, is iterative. It is an iterative process. So that's why even when you create a model, it's not done. You have to refine it. Even if your model is right, you still have to refine it in order to adjust it to the world, because the world is moving. So you have to constantly refine your model in order to make it compatible with the current situation. So now I'm going to show you a very simple example of how to develop a mathematical model, so you have an idea, because everything so far I taught you here is theoretical. All right, so let us say that you're a merchant, okay? So a merchant, and you sell two commodities. So apple and oranges. Apples and oranges, okay? And you sell these into two markets. So two markets. You sell your apple and oranges into two markets, okay? In the first market, the demand for apple and oranges is about, let's say, $20, right? And in the second market, that same demand is, let us say, $15, right? And in the first market, you need to produce, in fact, you don't know the exact amount of apple and oranges you need, but you need to produce 5 times. So in the first market, you need to produce 5 times the amount of oranges, no, of apples, my bad. 5 times the amount of apples, and 3 times the amount of oranges to meet the $20 demand. And then in okay, in the market. So here, let's say market 1, right? And then in the second market, so market 2, you need to produce 2 times the amount of apples and 1 time the amount of oranges to meet the $15 demand. All right, so this is all written verbally. All right, this is all written verbally. So now how are you going to translate that into mathematical language? So you know that you have 2 markets. So market 1 is M1 and market 2 is M2. So what you're going to do is you're going to now set up an equation that will help you determine the amount of apples and oranges for each market to meet the demand. So in market 1, it tells you that you have to produce 5 times the amount of apples. So let's say that your apple is X. Okay, so apple equal X, oranges equal Y. Okay, so 5 times the amount of apples, so which is 5x plus 3y equal 20. And then in market 2, you have 2x plus 1y equal 15. This is your mathematical model, and then you can either use substitution or elimination to solve this. Okay, so I can try to solve it real quick. So if we use the substitution, for instance, here you can use the substitution because you only have like a coefficient 1 in front of the y, so it's easier. If there was like a 3, for instance, in front here, it would be harder to solve it, like because you have fractions, so you have to use the process of elimination. So let's say, for instance, that okay, substitution, so you know that 2x plus y equals 15, right? So you simply do 2x. So you're gonna do this. Y equals 15 minus 2x's. All right, and then you're going to substitute this into, let's say, the first equation here into market 1. So it's going to give you 5x plus 3, 15 minus 2x's equals 20. Okay, so it's going to be 5x plus 3 times 15 is 45. 45 minus 6x equals 20. So you're going to put the x's together and the real numbers together. So it's going to be 5x minus 6x equals 20 minus 45. So it's going to be minus x equals minus 20 minus 45 is going to be minus 25. X equals 25. And then you simply use that and you put it in the second equation. So you know that 2 times 25 plus y equals 15. So it's going to be 50 plus, okay, so it's going to be 50 minus 15, it's, I believe, 35 equals y. And then so basically as a merchant, you know that you have, you know that you need basically 25 apples and 35 oranges to meet the demand for each. So this is a mathematical model that helps you solve the problem. And then I was about to give you another example, but this video is getting too long. Like for instance, when you use the logistic regression to simply determine a binary outcome, whether the consumer will buy it or not. We use that a lot in market research. I work in market research, and we use the logistic regression a lot to determine binary outcomes. So mathematical models are used everywhere. It is very interesting to see how they work, but I think you should do also your due diligence and basically do your own research. Watch a lot of videos on YouTube. That's how I learned how to develop mathematical models. I watch videos on YouTube, and I was able to learn how to create models based on how they teach. There are plenty of videos, you can't miss it. And if you want to become better at mathematics, I would suggest that you take Khan Academy. It is the best platform online to learn math. They start from kindergarten mathematics all the way to advanced math for university students. So it has everything you need. That's how I was able to bring my skills up to date. So I hope you enjoyed this video. I hope you found it informative, instructive. Let me know in the comment what you think, and until then, see you guys soon. Thank you.